everyone. Good morning, students. I am Munshi Rashidul Islam, Assistant Professor of Department of Mechanical Engineering, JIS College of Engineering, Kollani, Nadia. Now, I am going to present a new chapter. That chapter name is Design of Machine Elements Design of Braking System under the subject code is ME503. Now, first of all, we are going to overview some idea of braking system. So, first of all, what is brake? First of all, we have to know what is brake. So, brake is a mechanical device or by means of a mechanical member which is used to which is used to use the any rotating elements or any rotating member to slow down the speed of this momentum, but it is not only the to slow down or to stop the any a moving body. Another brake function is there. That function is obviously to absorb the kinetic energy or any type of potential energy. So both the kinetic and potential energy can be achieved by the braking system. So we know most of the students and most of the people are know that the brake is actually used to slow down the any moving body, or it is used to stop the any momentum body, but it is not totally 100% true. It is partially true, but in full phase of the braking system, actually first option is actually that is right, to slow down or totally stop. Braking system is used, but the secondary object is the braking system is used to absorb the energy. That energy may be in kinetic energy, may be in potential energy, and it is basically based on the different types of application that is actually familiar to the common man as a motor car or any type of bicycle. But brake are used on the both the cycles or bicycles or any types of um, vehicles, and it is basically situated on most of the cases. It is situated on the front wheel, but in the present scenario, it is actually attached at both the front wheel and also the rear wheel. That is actually the function or the application mode of braking system. Now let us see. It is actually a typical figure or typical example of braking system. And it is a most of all it is a Volvo type racing car with hydraulic braking system we have used in this system. And in the hydraulic braking system, hydraulic pressure obviously a one criteria, and another criteria obviously a helical compression type spring that is actually used as a shock absorber or vibration absorber, and that is basically a high speed type engine, and which is used for the racing car. Now next, the purpose of the braking system. The purpose of the braking system, the first one is stop the vehicle by converting kinetic energy to the heat energy. To stop the vehicle by converting kinetic energy to heat energy. Number one. Number two, heat energy is created in the brake by friction. So obviously it is a one parameter. When the body are in running conditions, when the body are in running conditions or when the body are in moving conditions, so the floor and the ground, floor or ground, and to the wheel or tire of the body of any type of vehicles, so there will be some friction will happen, and due to the friction some energy also be created. That energy is converted into the heat energy, that also the energy absorbed during this frictional behavior or during the frictional period. Now next is energy is created in the brake by friction. Next point is friction is created between a moving and non-moving surface at each wheel to generate the heat. So obviously friction also be created during the braking system, because one question is there: when the energy is absorbed, absorbed during the braking system, otherwise energy will not create any type of heat. So heat actually generated when the we continuously apply the braking load or braking force on that situation, and the heat is generated due to the friction. That is actually the friction is generated between a moving or non-moving surface at each wheel to generate the heat. Next is discs and drums are the most common type of braking system are used. So lot of types of mechanical braking system are there, but mainly two types of brakes are mainly used. Number one, disc brake. Number two, drum brake. Now these are the points. That points are mainly used. That is actually the system of the braking theory, and that braking theory is basically used to the purpose of the braking system. But most of the cases we know that the brakes systems maybe depends on some parameter. That parameter is, suppose first one is pedal arm. Pedal arm is the it is actually the arm, and which is actually attached to the pedal. Pedal means where we apply the load, on which portion we apply the load, and that load will be directly converted to the connected to the wheel arm, or converted to the disc or arm of the um, wheel. That is actually the pedal arm. And next, push rod. Push rod is actually the rod which is connected to the total load which is applied on the periphery of the portion, means brake lining portion, and connected to the pedal portion. That is actually the push rod. Next, master cylinder. Master cylinder is actually, it is basically used on the hydraulic braking system type, when the cylinder is used, and if I put the load, the cylinder inside the cylinder, total pressure, total hydraulic pressure will created on that area, and that area is thrust to the wheel or rim of the braking system. Brake lining actually the portion of the portion of the body of the wheel. If one wheel is 360-degree, but the brake lining are not on the 360-degree, it is actually covered by some certain angle to the center of the wheel. So some certain angle maybe depends upon the 60 to 70-degree angle, and that angle is based on the brake lining system. And that brake lining system is actually the, it is lining means the portion which is actually created some pressure on the wheel of, or wheel or disc of the braking system. Next, proportioning valves. Proportioning valve, that also be one special part of the hydraulic braking system, and it is also some certain type of valve which is actually used to some open and close type system. and that system valve are basically used to the some specialized load. That load is based on the applying capacity of the total periphery load. Next, T joint. T joint, that means it is also one type of joint which is actually used to join the different types of parts in shape of the English letter T, and therefore that's why it is actually a T shape type joint, and it is actually covered whole the process system of the braking. That braking system, it when if I apply the load, the fast thrust actually bear on that portion, and that portion is actually based on the some certain angle. That angle is actually created by the casting method. Next is flexible lining. That also be another part. That flexible lining is actually used to cover up the brake lining, and that brake lining portion is covered by the flexible lining, and that is actually maybe some metallic part or maybe some plastic part. That also be covered by some certain portion of the total wheel portion. Next is caliper. Caliper, mainly two types of caliper that is actually used for the designing of the braking system. One is a annular pad, and another is circular pad. And so both the mainly two types of pad that is actually used, and that caliper is actually connected to the pad, and it is also another type of shape that is actually used. Now, braking system, and mainly if you see the actually figure, that figure in the right hand bottom figure, that figure it is actually a braking disc brake, and which is actually a circular portion with some certain area of radius. That radius, if I see the periphery of the disc, periphery of the disc, lot of holes are there, but one question is there: why these holes are needed? Because these holes are needed, it is actually these holes are used for dissipating the total heat when the body are in running conditions. So when the bikes are in running conditions, some heat will create, or some heat will generate, and during this generating heat, if I some putting a hole, that hole is actually passing the air through one side to another side, and we know that the air is a perfect lubricant. So for this reason, these holes are needed to dissipate the induced heat to the atmosphere, to release the atmosphere. That's why these holes are needed. But some companies, that hole may be in half semi circle type or any other shape type, but these holes or semicircular holes, that is actually used to dissipate the total induced heat to the environment. Now next is braking fundamentals. Braking fundamentals, obviously the braking system components, drum brakes and components, disc brake and components, anti-lock braking system and components, and braking procedure. These are the parameter. These parameter are used for the discussing of the braking system. So braking fundamental, that is actually the fundamental how to create the braking system with some reference, and it is basically based on the different types of mode. That mode maybe depends on some special parameter. Braking system. Now braking, a lot of braking systems are there. So we can discuss the different types of braking system. That braking system, suppose shoe brake, band brake, disc brake, and internal expanding brake, hydraulic brake, etc., etc. But one question is there. So some factors are also involved in the calculation of the brake system. So that basic brake calculation to relate the different types of determining the factors. So that factors may be depends on some different parameter. So number one is energy absorption capacity. Energy absorption capacity, that means how much energy can be absorbed during the braking system. So that is actually now number one point. Number 2 points, torque capacity. That is actually one type of application of braking system. So how much torque will be created during the braking system. Next is actuating force required. That also another point, the how much force is applied during the braking system. Next is heat generated. How much heat can be generated during the braking system and or braking period. And then that next point, that will be forces in the hinge pins, and obviously the forces in the return springs. Forces in the return springs, that means if I apply load during the braking system, it is not a continuous process to press the pedal in infinite times. It is not possible. Braking system, that means in some certain time it can be applied. When my requirement is fulfilled, we can easily release the load. That means the forces in the spring, that is actually apply load, that load may be released to the original conditions. Next, length and width of the friction lining. Length and width of the friction lining, that also be another point. That point is discussed in the brake drum brake system or any type of disc brake system. Required coefficient of friction. The required coefficient of friction, that means frictional behavior, that also be counted during the braking system. And last point may be counted on the unit pressure on the friction surface. Unit pressure on the friction surface, that means pressure also be calculated. That means if I apply the load on the brake lining, so intensity of pressure, that is actually the conditions to pressurize the total applying load. So intensity of pressure must be calculated in the form of brake lining system. That means some certain portion of the wheel or rim of the um, braking system. That braking system, that means that portion not covered the whole portion of the wheel or rim. That's why we can discuss the brake lining system. Next, now braking fundamentals. So first principle, that is actually friction between the braking surface convert kinetic energy into heat energy. That is actually the friction fundamentals, braking fundamental. In drum brakes, while wheel cylinder forces brake lining against the inside of the drum, and in disc brake, pads are forced against a brake disc. So lot of systems are there. So we can consider the different types of mode of applying load. That load may be varied on the just like friction behavior, friction lining behavior, inside drum behavior, etc., etc. That is actually the basic fundamental principles of braking system. Now, several factors can influence vehicle braking. Number one, that is road surface. Obviously, road surface is another important point. Next is road conditions, weight of the vehicles, load on the wheels during stopping, and next point is how the vehicle is being driven. So that five parameter is also important point, how to influence the vehicle braking system. Now next point is a basic braking system. That a basic braking system means some points are to be counted when we apply the braking load on the pedal. So number one is actually brake pedal, that also be needed to fulfill the total braking system. That is the basic criteria. Number two, master cylinder to provide hydraulic pressure. Number two. Number three is brake linings and the hoses are to connect the master cylinder to the brake assemblies. And next point is brake assemblies, drum or disc that stop the wheel. That means if I apply the drum brake, we can use drum to stop the wheels, or if I use the disc, that also we used for the stop the wheels. And it is basically used on disc brake, basically used in most of the cases. It is used in front wheel, but in rare cases it nowadays it is actually used both the axis of rotation. That means it is used front wheel as well as in rear wheel. Drum and disc brakes. Drum brakes have a brake shoe that expands against the inside of a brake, and disc brakes clamp a flat disc between the two pads. So drum brakes, it is actually used for the purpose of the inside of the drum, and in disc brake it is clamp on the flat disc between the two pads. So when the two pads may be annular type or maybe in circular type. Coefficient of friction. The coefficient of friction in the measurement of friction between the pairs of surfaces, that is actually counted during the braking period or during the braking systems. Stopping distance. The distance in which the vehicle stop by applying force. So that is actually used for the calculation of the stopping distance. Brake fade. It is the reduction in the stopping power caused by a build up in the heat of the braking surface. Weight transfer. In dynamic braking systems, in dynamic braking conditions, weight transfer from rear wheel to the front wheel. Weight transfer from the rear wheel to the front wheel. How it can be possible? It is actually possible when we press the front wheel, or when we press some certain time in the front wheel, the most of the load is converted into the rear wheel to the front wheel. For these reasons, when we applying load, the weight of the body or weight of the whole body will bend to the front position. For that is actually the case when we apply the load in the pedal. That is actually the weight can be transferred from rear wheel to the front wheel. Skidding. Skidding when force is braking exceed force of adhesion between tires and the road. That is actually the skidding. Drum brake. And that is actually the figure of drum brake. If I see the in the figure, drum brakes have a drum attached to the wheel hub, and the braking occur by means of a brake shoes expanding against the inside of the drum. And if I see the figure in right hand side, the brake cylinder is there, piston obviously inside the total drum, and outside portion is drum. One certain small adjustment is there, that is actually called the adjuster mechanism. Brake shoe obviously inside the drum, and that is actually a red type portion. An emergency brake mechanism also be there. And in this system, braking system, a drum brake is a brake in which the friction is caused by a set of shoes or pad that press against the inside inner surface of a rotating drum, and that drum is connected to a rotating wheel. And next, how to differentiate the drum brake and a disc brake. But I explained this in this slide, but it is not properly elaborate these slides, because disc brake and drum brake, both the brake design is actually completed, then we can differentiate. But it is actually theoretical part, so that's why we can explain here. uh, Left hand side is disc brake, right hand side is drum brake. In disc brake, what are the actually advantage and disadvantage, and in drum brake, what are the advantage and disadvantage? Number one, better ventilation property than drum brake. And in drum brake, low ventilation property is there. Now in disc brake, uniform wear of frictional forces between the pads and disc. And in drum brake, non-uniform wear of frictional forces are needed. In disc brake, design of disc brake is easy, because it is the small part that is actually engaged to the wheel of the or drum of the braking system. And in drum brake, it has complex design. In disc brake, disc brake have low weight, and in drum brake, 20% of more weight than disc. Now, in disc brake, it has better anti-fade characteristics. That means the braking fading system are very much useful than the drum brake. So in disc brake, it has anti-fade characteristic, but in drum brake, it has poor anti-fade characteristics. And in disc brake, replacing of frictional pads is easy. That means if any pads are lost by some wear, we can easily replace by this pad very easily. But in drum brake, replacing of frictional pads is too much difficult. That means the replacing of pads are very easy in disc brake, but in drum brake it is not possible. It is too much difficult for changing the pads. And last point is total frictional area of pads on disc is less. That means small area are covered up by the disc brake. And in drum brake, total frictional area of pads in drum are more compared. That means the more area are needed for the drum brake, and that is the actually fundamental difference between the disc brake and drum brake. and most of the cases we can use both the brake system. But as our requirement, when the disc brake is required, we can use this type of brake. When drum brake is required, we can also use the drum brake. That is actually the difference between the disc brake and drum brake. Now in the next class we can discuss the design of disc brake, how it can be operate, and what are the advantage, disadvantage, etc., etc. All the points can be discussed one by one. Thank you for this lesson.